down 30%, but actually from point A to point B. So like our
things with speed, then you gotta use that.
Technically not. It's technically not true because when you use speed to explain light, you're inferring that light is moving from A to B. Light doesn't actually travel; it induces. So it's a rate of induction.
Yeah, but that's not the. Yeah,
say speed.
Yeah,
which
but
has
we're
a time
saying
interval.
that.
It's just, so you're saying light speed's instant?
Yeah, well, okay. Well, technically, the light's already there, and there's a rate, which rates aren't instant. There's a rate of induction, not travel, from point A to point B. So, like, our explanation can perfectly explain the laser through the glass, right? If you shoot, quote unquote, shoot a laser through the glass, and it looks like it slows down 30% and then exits it and speeds back up, we know, based on the law of conservation of energy, that light can't actually be physically speeding up once it leaves the glass because it would need more energy to make it speed back up. So that means now their explanation is, oh, well, it looks like it slows down 30%, but actually it's just traveling a greater distance inside the glass because of the material impedance of the glass, of the medium, right? So it's just traveling a greater distance. And so it looks like it's slowing down, but it's actually going the same speed the whole time. And then now that it's outside of the glass, there's no material impedance, so its path is shorter again. So then it looks like it's speeding up. Our explanation would be, well, actually, light is just like a visible light, right? It's just the excitation of what's already there. And so it's a background medium that's excited. When you add an additional medium like glass, now you've put a whole other medium of material there that you have to perceive that excitation through. So how quickly you can perceive it slows down because now there's a whole additional medium layered on top of it that's causing the perception rate to slow down. That's why it can instantly be perceived faster again, because now that medium's not effectively impeding your visibility. Like, that explanation makes perfect sense because it's just as you layer more mediums, you don't see the light illuminate as fast, right? Because now there's more stuff there blocking your perception. Does that make sense? Like, the light is the background. If you see it in a vacuum, there's nothing additional there. So every medium you add to it is actually slowing it down in the sense of how quickly you can perceive it.
But it takes longer. It takes longer to get through the glass, though.
Perceivably, it takes longer to perceive the light. It's like, okay, sound. If I scream down the street to you, and it takes a second to hear it, like, there is no sound wave that physically leaves my mouth and travels down the street to you. That's not why it took a second, because sound is actually the air vibrating, right? Because you don't have sound in a vacuum chamber. Sound is just the air vibrating. So there's air around you down the street and air around me at the whole time. So the air didn't travel.
Remember, we're analogizing to
right?
light. We're analogizing this to light, right? So it's a vibrational field disturbance, to be most accurate.
Yeah, but when we're talking about
right.
when we're talking about light, the light we can see, we're talking about the vibration you hear, just like sound. It goes from my mouth to your ear, basically, those vibrations.
Right.
It's like being
almost there. So
it's like being in the middle of a pool, flapping your arms, and the waves overlap the edge of the pool. You're not actually touching the edge of the pool. You're creating a disturbance within that medium that's visibly, phenomenal, being illumination, i.e. the byproduct of light, because light itself is not visible.
Right, just real, give me just a couple more seconds. So Tesla, for example, said that light can be nothing more than a sound wave in the ether. Okay, what's a sound wave? It's the vibration of air. So sound is actually just air vibrating. Okay, so if you take away the air, you have no sound because it's just the waving of the air. It's the medium waving. That's what sound is. If you take the medium away, you have no sound because there is no corporeal thing called sound waves that exist on their own. It's just the air vibrating. If you take the air away, you have no sound. Now apply that to light, right? Light is the background medium. Okay, so as you add air, now you're adding an additional medium that's actually gonna block it more. If you then add glass, it's gonna block it even more. All you're doing is layering mediums on top of the medium that actually is light. Just like sound is just the medium, light is just the medium, but it's different medium. Sound is air or material medium. Light is an immaterial medium. So as you add material mediums on top of it, it slows down how quickly you can see it.
When you're dealing with clear, transparent mediums such as air, glass, liquids, oil, whatnot, you're dealing with dielectric insulators essentially. And when you're dealing with like reflective metals, you're dealing with dielectric reflectors. So I mean, it's all analogous.
Do both of you have Ken's script up right now? What is going on?
No, I've got it memorized. No need to have it up.
Oh, my bad.
Like that's all you got, right? Because you can't respond to the specific. I just invoked Nikola Tesla. Yeah. So Nikola Tesla has nothing to do with Ken Willer.
I feel like you were trying to butter me up with Tesla there. But we were talking about the speed, though. Like the speed of sound, the light, the illumination takes, it takes time for it to go from one spot to another spot. That actual, I know it's always there, just like the sound's always there, but the illuminated part, that takes time.
Yeah. You can't use speed to explain it, Jeremy, because you're automatically invoking material emission or traveling, and that's not what we're talking about. And it's kind of a mind fuck when you start using those words, because you're automatically assuming, based on the fact that we've been indoctrinated, that everything is particle interaction. You fall right back into the loop, not understanding. So you have to infer the proper terminology, i.e. rate of induction, and then understand what's being said when we say that. No speed here, Jeremy. No trains, planes, or automobiles here, bro.
But doesn't perturbation means movement? Perturbation means movement, though. It just means, it doesn't mean that one thing is moving from one spot to the other.
It's propagation. Perturbation, propagation. It's what it is. It's a field disturbance. It's a
that's movement.
Whatever the word I was trying to.
That's movement. It's not linear movement from one point to the other, but it's movement being, quote, transferred.
Correct. Yes. It's a disturbance. It's just like if I'm in a lake and I start waving my arms in the lake, right? The water moves for sure. It's displaced. It oscillates, goes up and down. It moves, but it doesn't travel across the lake because the water was already on the other end of the lake. If I watch a wave go all the way through the lake and then hit the shore, how long did it take the water to get to the shore?
It's kind of like the piston.
Yeah, but you're talking about the hump, though. Hold on, Iceland. But we're talking about the hump, though. Just like the sound, we're talking about the vibration, the water. We're talking about the hump, the light. We're talking about the illuminated part, the part you can see.
That's where I was going.
Yes, that's where we get the speed of light. That's where we get the speed. Good.
Yeah, the pistons in your car aren't moving the same direction as the car, right? Like the pistons in your car are going up and down, whereas the car is going forward.
No, that part I understood, but just like with sound, from when the wave first appears at one location to where it appears at another location, there is a speed, right? So for that perturbation wave to reach from one point to the other point, there is like some speed, right? It's not that is not instantaneous. The medium is instantaneously there, but there is a speed from which you see the first. I mean, if you could.
What did Witsit say speed was? It's distance over time.
Yes, but let me just clarify. Where we get the speed of light is how quickly we perceive illumination. That's where we got the speed of light. Rate is technically a speed. It has time. It's movement, time, speed. So rate is technically a speed, but it's not travel from point to point. It's just a rate of induction. It's a rate of illumination. It's how quickly it illuminates. We actually got the speed of light from the permeability and the permittivity of a vacuum from Maxwell's equations.
Let me say this real quick. I tried to briefly analogize on the guy in the middle of flapping his arms, right? And that wave-like pattern that's propagating in all directions is eventually hitting the edge of the pool, right? As he starts to flap his arms, the water's, before he even flaps his arms, the water's perfectly still. He starts to flap his arms. Now, all of a sudden, these waves start propagating in all directions, and eventually they reach the edge of the pool. And how long did it take for the water to get there? Well, the water was already there to begin with.
We're not
No,
talking about the water, though. We're talking
It was
about
the
the wave
disturbance.
part, the
I
hump.
understand. I understand. It was the disturbance of that water which took time to reach the edge of the pool. And that's analogous. That water and that disturbance would be analogous to visible light, i.e., illumination,
sure. So,
where the water that was already there would be analogous to light in its full totality. We're just talking about the disturbance of what's already there requiring
understood.
time.
That part is
Right.
understood. So let's instead of using the word speed, because apparently speed is reserved only for distance over time. So how much time does it take from one point, from the origin point in the lake example to the edge? How much time? Similarly with light, how much time does it take to get from point? Not
Well, it
point.
actually varies. It's variant. See, that's the whole deception. See, because it isn't some corporeal thing that's physically traveling and has a maximum speed limit. It's already there. It has no speed limit. So it varies. That's why in one direction on the earth, it's different than the other direction. That's because there's actually a preferred direction within the ether because there's a drift. So, like, that's the whole trick, is that the speed of light, quote unquote, is actually variant. It changed. We have superluminal propagation. And what they say is, oh, they come up with all these mental gymnastics to explain superluminal propagation. They just start making stuff up. But no, it's just because there's less impedance to how quickly you perceive the illumination. That's it. So, like, that proves that it isn't some, like, corporeal thing that physically travels from point to point. It's already there, and all we're quantifying is the differences in how quickly it is excited or illuminated.
That's better. That would be the rate of excitation reaching or something is like what is that? Is that because I'm taking umbrage with perception, because I don't. There's also like non-perception based experiment like interferometry. Isn't that
Sure.
based on the fact that there's a you can objectively measure
Yeah.
a rate within a medium?
Yeah. Well, yeah, because the C is generally accurate. We got that from the permeability and permittivity in a vacuum. So, like, when we try to get as much air as we can out, and then we measure the rate of induction or excitation, that's called light, then we get permeability and permittivity giving us C, right? So that's where we got the value. It's typically correct. But that it's not an actual finite hard limit to the rate. It's just generally the fastest you're going to see it go. It requires specific situations to see it quicker. And yes, it's not just visible light. You're correct. You can use things that aren't visible or don't require perception. But the problem is that usually when people say light, they're actually talking about visible light. And then they conflate light and illumination. No, visible light is less than 1% of the spectrum of light.
No,
Right? Like,
It's
it's
actually
just a
less than that.
certain version of the light. Yeah, it's less than 1%.
Way less than that. Yeah.
No, we're in agreement that there's no actual physical distance being covered by any sort of corporeal particles. That 100%. But there is a rate of excitation, not just perception. That's what I'm saying. Because perception.
Yeah, that's true. That's true. Yeah. I guess the reason I say that is because, well, what visible light, this is more accurately stated. Visible light is actually just illumination, and what people call the speed of that visible light is actually just the rate of induction or perceived illumination due to the excitation of the medium. And, like, people their brains melt when I say something like that. They're like, "Oh, word salad," because I said too many words with syllables.
It's
But that
akin
was a
to
very specific.
a terminal velocity, except it changes at different altitude because the density of the air. So it's a variable concept.
Yeah, it's like, you know how, like, okay, say let's just use sound this is why Tesla used sound as an analogy, because it's such a good analogy. He said that light can be nothing more than a sound wave in the ether. So, like, if I'm talking to you in the air, and then I try to talk to you through, like, many, many feet of concrete walls, then you're not going to be able to hear the sound as well, or it's going to take longer to hear the sound. Because now you've added an additional material medium to the air. So now the more compact material has to vibrate to hear the sound, right? As you stack on more material it changes what people call the speed of sound. Same thing with light. The only difference is that sound itself is the air. It is the medium. Sound is nothing more than the vibration of a medium, a material medium, where light is the vibration of the immaterial medium. And so when you add material mediums, you're actually impeding light. You're holding it back because it doesn't need its existence is outside of material. That's the difference between sound and light. One is material, one is immaterial.
There's a bit of a philosophical conundrum also, I guess, from the part of, like, let's even say from the part of the creator, God, whatever you want to call it. Because as you start removing medium, light, the rate of induction of light increases, right? And then, but at the point of the ether, imagine if the ether was to be made non-existent. Well, then there couldn't even be any travel. So it has to somewhat exist. Like, I think you use the word tenuity, right? A tenuity beyond comprehension or whatever. But it's still got to have something.
Yeah.
Otherwise, no movement would be possible. So,
you would have
Well,
to.
there is
You would
yeah.
have to demonstrate that there is such a thing as a void space of no qualities, and there's no such thing.
how we
I
get
mean, you still
centripetal
have the
convergence.
space there, which includes potential. So you cannot remove all qualities of any kind of spatial amount.
He is making a profound point, though. He's making a profound point, though. Like Nikola Tesla said that you can think of the ether as a gaseous substance with tenuity beyond comprehension, which means thinness. So, like, if you got to the thinnest amount of air, the ether would be way more tenuous than that. Because he said that to try to convey the concept to us, which it is just a more thin version of air. It's the primary state, it's the primary substance. I think it's just for conceptual purposes, though, because it's immaterial, as far as we can tell, right?
Even in the mainstream paradigm, they say that atoms are like 99% empty, but we're saying that empty space is actually just another medium.
Sure, but even though it's so tenuous or whatever word, right? It's still got to somewhat be there. Otherwise, not if it wasn't there, then even the waves would have no medium to, like, wave in. So it's got to
for sure.
And that would kind of impose.
It's there. It's absolutely there. It's everywhere.
It's the dielectric field, and that's how we get, like, electrostatics and many other things. It's the centripetal convergence, the primary half of the magnetic field, being the sink, of course, which everything's kind of like sucked into analogously. If we were to explain it with a shower head and a drain, where the water coming out of the shower head centrifugally diverges and then is collected at the bottom of the floor there at the shower pan and pulled back into that drain in a centripetal converging matter, creating this toroidal force vector. And that's how we get the hyperbole and toroidal geometry of the ether field processing and creating this vortexual pattern as witnessed within all matter. Yeah.
One of the
How we
best
get the
evidences
golden
is
ratio.
wireless power induction in a vacuum. So, well, what's up with that? Or what's up with the Casimir effect, right? Like, there's something other than air that is a medium that sustains electromagnetic phenomena. Right, and so we can talk about what it is, and that's where we get into speculation.
They'll just say you don't need a medium, though, right? Just be like, fuck it, you don't need a medium.
Yeah,
for
but
that
that's
stuff.
it's just stupid, though. Like, that they're basically saying that it's nothing, that there's nothing there.
Even if they say this, if you could actually, like, with rigorous metaphysics, even if they say that these light are photons and they're traveling in a wave, right? So they're corporeal particles that are traveling in a wave. Well, then there still has to be something guiding them to travel in that wave. Otherwise, they're going to have to say that these things are actually they're going to be panpsychists, and that these light particles actually coordinate themselves into a wave. The whole notion of is actually a misnomer. You can't just have this. You can't have inert matter, but also have it have properties. Properties are ascribed from a metaphysical domain. They don't just because inert and to have some sort of behavior are actually, like, contradictory to each other. So even if you had particles traveling, something would be guiding them in the wave. Otherwise, they just wouldn't go in a wave.
Yeah. Yeah, that's a pretty profound point, similar to like what's the antecedent to the intrinsic order of equilibrium. But yeah, you're way over the mark for some the people denying the
Yeah, that was
background now.
that was pretty good, dude. I don't think I've ever heard this guy before.
Yeah, he's dope. He has very sound epistemology.
You would have to have a medium, correct?
Yeah, of course. Yeah.
So then when the energy or whatever you say the input is, it cites that medium, there's going to be things that happen. I think that's what light is. It's just energy input into whatever medium we have. It flows
that's
out.
kind of why. That's kind of why early on I tried to correct you when you were analogizing sound to light, because when you say medium, we're talking about the field ultimately, right? And
That guy's
fields
screen name. What
fields
was
are
that guy's
not
screen name?
fields are not. Go ahead, Jeremy.
Never mind.
Sorry.
My bad. Go ahead. Never mind.
Yeah, I was just saying fields are not like made of particulates, where when we talk about mediums such as like water, for example, there's obviously atoms within that, i.e. particles. So my point is that we have to be concise when we're talking about light, in the fact that we're talking about a field, and the lack of a medium within that field is where you run out of having visible light, i.e. illumination. Somebody's hot micing, because the fact that illumination, i.e. visible light, requires a medium. So there has to be a medium in order to have illumination, but light doesn't require a medium. Go ahead.
Yeah,
I
what
see
was
the
that guy's
field
screen name?
within
Real quick, what was that guy's screen name? So we all know, because I don't know. Does anyone even know?
What guy, Jeremy?
The guy everyone was like, "Oh, I like this guy."
Oh,
What
that was
was his name?
Arul, Arul, or something along those lines.
That's Kosho with a voice changer.
Oh.
No, it's not.
No doubt.
But wouldn't the
Yeah,
field
because I've
be
never gotten
within the
it.
medium?
Well, like if we think about this, we have waving, right? So waving is a type of movement. So if in a vacuum chamber we have waving phenomena, electromagnetic waving, what is waving?
Movement of the medium or field, or movement of the medium within the field. It's energy input. Once you start movement.
Something has to be there to wave in the first place.
Correct.
Waves just don't happen on their own.
Yeah,
So if we were to
just
follow
movement.
this logic, to explain the stars from a terrestrial observation, what would you guys conclude?
Wait, if we were going to do it to explain what?
To explain how we view the stars from here, from standing on the surface. Like when we view the stars, if we're going to follow this logic of explanation behind light, as we just laid out, what would we conclude in order to have illumination from those stars being witnessed?
Each star is creating its own individual disturbance. So what
Right, but
is it? I mean, good question.
well, like I just said, like in order to have illumination, you have to have a medium or an object.
How about a superfluid? Would a superfluid wave?
Yes.
Interesting.
Yes. If you had a concentrated enough vibration, you could have superfluid wave. Yes.
That would be an explanation.
Yeah, that's where I go all the time.
Shout out Rakia.
Have you seen the room temperature superfluid that they're saying they've found or whatever? And I think that has to do with the energy, being able to charge your cell phone above the pad or whatever it may be. It's a superconductor at room temperature and pressure. That changes the whole world, basically, if that comes out.
Yeah, good find there, Rakia.
Yeah, they did.
That was pretty impressive. Yeah, superfluidity at room temperature. That changes everything.
Yeah, they literally just came out not long ago saying that they've been able to accomplish quantum levitation are quantum locking, magnetic levitation, and room temperature, and superconductivity and room temperature.
Exactly. Yep.
It's
Exactly that.
likely
That's
not
crazy.
an
It's
actual
crazy.
room temperature superconductor, guys. It's not. It's probably not. It seems like it's just a dipole-dipole interaction, which somehow results in this superfluid.
Really?
Those are
Do you
two
even know what
things.
we're talking about? How they had a
Yeah.
superconductor
Superconductor,
and room
sorry.
temperature?
Yes, it's probably not an actual real superconductor, though. It seems like it's a dipole-dipole interaction.
So this is what
There
this guy
actually
does.
is
He
no
immediately
dipole
reads
magnetic moment, but
what any mainstream article says to try to explain away how it doesn't comport to the current understanding. He immediately has to believe
Bro,
that.
the mainstream right now thinks it is a fucking superconductor. Realistically, it seems like it isn't actually a superconductor.
Oh, okay. It just
Did
has
you
all the
look into
qualities
it,
and
or you just
characteristics
read
of
the
it.
first article that you came across?
The first article I came across, fucking every article I've come across has said it is a superconductor. What the fuck are you on about?
Calm down, bro. I just asked you a question. You don't got to get excited.
You didn't ask me a question, you stated a thing.
Okay, but this is new, relatively new discovery, right? So they're going to be looking into it, just like the 5 Sigma discovery. This is new stuff, bro.
Yeah, there's a
Mm-hmm.
paper from August 4th.
Hold on,
August
whatever
4th,
this
2012.
is, whatever this room temperature superconductor thing is, what is it gonna? What can we do with that? Some
Bro,
cool
no
ass
more
shit or what?
tires. No more tires on trains.
It's
We'll start
limitless.
there. Yeah.
Limitless as far as energy and movement and like paths of things, anything. It takes away all the limits that we have right now.
Here, motor,
Yeah,
Like
it
it would.
doesn't
the
matter what this
motors
guy.
that have impedance, right? A motor that has impedance. Imagine a motor with zero impedance almost. Imagine how much
Well,
more power they can get out of it.
here,
That's just
here,
one thing.
here's the thing, though. I got in a Jesse with this one day, and he said there's no. They say it's frictionless, but it also has drag, which didn't really
Oh
make
man, I
sense to me.
remember that conversation. He was just double speaking the whole time. Anyway, I just dropped a paper right here, and it exhibits superconductivity. So just this is it looks like a dipole interaction. It's not actually a superconductor. It exhibits superconductivity at ambient temperatures.
If you
So
That's
look at the
huge.
entire interaction thing, there's this one graph where it dips everywhere around the exact temperature and exact conditions that the superconductor was at.
hey, did they accomplish superconductivity at ambient temperatures?
Under these exact specific things with this exact specific material, it seems as though they have. What I'm trying to say is it's not realistically, it's probably not that.
Oh, so you're just appealing to incredulity.
But the effect is
No,
the
I'm
same, right?
saying no,
But
I'm
hold on.
saying literally. Okay, the thing is with this thing is if you even change the variables by a tiny slight bit, the superconductivity just fucking disappeared.
That's
But
irrelevant.
the effect is the same, right?
He
Under
just
The effect
admitted
happens with specific conditions.
he just
well,
admitted the superconductivity. It's just when you change the variables one little bit, it changes it. I agree with
yes, but
him.
again, if it's like
Yeah, exactly.
22.1 degrees, it works, and then 22.2 degrees, it doesn't work. Is it really a room temperature superconductor?
Yes, until you
Yes.
change the variables a little bit. Jesus.
Yes.
Okay, so what I'm trying to say is, only under very, very precise conditions is it a superconductor, which means there's
That doesn't
probably
matter.
something underlying going on, not just the fact that it's room temperature.
Wow,
Irregardless
dude.
of what it is, they have done it, correct? In this one instance?
Yes.
Yes or no? That's a
Yeah, I just
yes,
dropped
right?
the freaking
Buddy?
Maybe is the answer,
I
yeah.
just dropped the
Maybe.
paper.
Wow.
I just dropped the paper though.
But he is kind of right about the maybe, because this has come out before and it was proven to be a farce. But this one seems to be more legit, and if you really look into it, it's coming. Like, so why wouldn't this be true, or it might be true 10 years from now that someone actually did it and put it in paper form and got it peer reviewed and all that. So he's kind of right on that. It still might be a maybe, but you have to logically deduce that it's coming. I mean, if you agree that superconductivity has been done in other temperatures and pressures, then they would then start working on, bringing it down to room temperature or whatever. And that's what they're claiming they've done.
I mean,
Correct,
room
because
temperature
obviously you're going to have specific conditions because it's about a ratio of energy. That's how you get superconductivity, and that's why we use temperature, because it enables us to establish that required ratio more effectively. So if you start to change the temperature towards an ambient temperature, then you're going to have to alter the rest of the variables to attain that ratio. So of course it's going to be very specific, certainly when you first discover it, but it logically makes no sense to claim that superconductivity would be impossible at ambient temperatures. It doesn't even make sense. Physics scales. So if you're able to establish the same ratio of energy, then you're able to establish superconductivity at ambient temperatures. So you're acting like it definitely shouldn't be possible. In reality, it definitely should be possible.
Bro, I'm not saying it shouldn't be possible or isn't. I'm just saying for this specific thing, it looks like it's not actually going on what they're claiming, or at least what mainstream is claiming about it. It isn't just a room temperature superconductor because of the material that it is and the way that it is. It seems as though there is something going on at this exact critical point that causes it to act as though it is a superconductor.
Well, this has been peer reviewed. I mean, this is the exact process that most people in the scientific community dwell upon. So if they're saying it's been peer reviewed, it's put out in papers, and they're claiming it's done, then why would you even fight against it?
I'm sorry, has it been peer reviewed?
Yeah, I just dropped the paper.
Said it has, yeah.
From what I've seen, it seems like it's literally just this one paper has been dropped by a thing, and now it's under peer review.
Have you actually researched it?
Yeah, I don't know about that, but they're saying they're going to win the Nobel Prize.
Well, yeah, if it is an actual real superconductor, yes, they probably would.
Well, I mean, this is the scientific community. This isn't like Joe Blow sitting on his couch saying, this is amazing. This is the best discovery in physics in 100 years. This is actually put out there in the public. That doesn't happen on a whim.
I mean, dude, this is the facts, right? Like, they accomplished superconductivity at ambient temperature. That's a fact. If you're saying, oh, well, maybe it's just like superconductivity, but actually it's not superconductivity, you're just making stuff up. I don't know how we're even supposed to engage with that. Yeah, it's just like superconductivity, but it's probably not.
So with the whole peer review thing, it's being peer reviewed right now, and the tests that are coming out right now, they can't really replicate it. It hasn't actually been peer reviewed yet.
Would you agree that not just anybody could write a paper? Like, it has to be somebody that they take serious, right? Just not anybody could just drop a paper down, right?
Yep, I 100% agree, yeah. But It's being peer reviewed right now. That's the point.
Okay.
I mean, I have no problem. Like, people can make all kinds of claims that aren't true. Like, they can claim they did something in their lab and they didn't really do it, right? And it should be able to be replicated if they did do it. That's definitely true, right? But you're suggesting that if they did actually do it, it doesn't mean it's superconductivity. That doesn't even make sense.
Okay, so a superconductor is a material which will conduct things with little to no resistance. It seems as though it's not actually just the fact that it is this material that makes it a superconductor. There's some fucking ion transfer, some bullshit somewhere going on at an exact critical point which makes it appear to have superconductivity properties.
This dude just said there's probably some ion transfer bullshit going on. Okay.
Yeah, that's why
Well,
I said bullshit, because I was making
I'll write
something
that.
funny up off of the top of my head, man. Calm down.
All right. Well, I'll write that down, bro.
Well, doesn't it
Did the
seem
joke
to
go over your
reason
head?
that
Calm.
doesn't it seem to reason, bro, that whatever it is, right? It's something that mimics superconductivity. So whatever it is, of course, it's not the cold, right? It has to be another mechanism, no? So doesn't it sound to reason that, yeah, it would be something else instead of the cold?
No, because
Obviously.
if there's some energy intake going on from somewhere else, then it would not be this groundbreaking thing that it is. So let me give you what it could be. Something like the material is destroying itself from the inside to power this superconductivity. That would be nothing to us, because it would be the exact same as fucking really cold superconductors. We have to add in loads of external energy.
With this
Yeah, but that's a big leap.
technology, with this technology though, would it possible to be like have a tube of it and then send something like some matter or something faster than the speed of light through it, or like what are we gonna do with this thing?
No. That's never
it
gonna happen.
would just revolutionize electricity.
Okay, Jeremy,
Well,
imagine a wire, but a wire that has absolutely zero resistance. You just turn energy, the human energy that we have would fucking multiply by billions if we had room temperature superconductors.
Yeah, you'd be able to run your cars. Like you'd have electric cars that run freaking thousands of miles, and you would be able to do. You wouldn't have to have utility bills because it'd be basically free.
you're
It's
talking about
basically free energy.
implosive. You're talking about implosive technology, i.e., instantaneous, non-lossy, over unity, and what was the third thing? Longitudinal propagation instead of transverse, so it's instantaneous.
It's
Hold on,
everything
before
wrapped
you
into one.
you had me at over unity. How do we get over unity with it?
Well, Ken just put out a video. I haven't watched it yet, but supposedly the title of the video says "Over Unity, Ion Propulsion," and then in the next sentence it says, "What does it say?" It says light drive fuel." I don't know. Sounds pretty interesting. I kind of want to watch it.
It's not a coincidence that all the levitation propulsion systems and the free energy is coming out. I mean, I think that's what this has to do with. There's no heat transfer. If there is friction at this temperature, it's very little. So you get long-lasting effects that, I mean, it's basically free energy. It's everything that everyone's ever dreamed of, all wrapped into one. And once they conquer it, it changes the world. Like, I don't even, like, weapon systems, propulsion, energy, everything wrapped into one. It's craziness.
Yeah.
Well, look, the
Imagine
reason why I'm skeptical.
frictionless gears for one. Frictionless gears.
Yeah, you can make UFOs, maybe, huh?
Uh-huh.
Yeah, exactly. You could actually physically put something in the sky and make it follow a certain path with programming. Like that's kind of like where it's headed.
Well,
Look, the
supposedly,
reason that there's. Go on, Dice.
oh, go ahead. Yeah, I was gonna say, because I mean, you guys know I'm a fan of Ken, and he says it's possible to have this like solid state drive over Unity device and have basically UFO technology, if that's what you want to call it. He said it's just a dielectric arc form, and he gets further in depth as to explain what it is. But go ahead. Sorry.
Yeah, you said Nick Cannon's your favorite rapper, no doubt. Go ahead, pick a username.
The reason I'm skeptical of this team is because they've done this before. They've claimed to make superconductors at room temperature before. In like, I don't know, fucking 2015 or something. They claimed to make one before, and their paper had to be redacted because of how many flaws there were in it. And they've even redacted parts of their paper already now. It's to do with one specific method they had. It's not the whole paper, but just one small part of it has already been redacted. It seems as though, and I think there's only been 2 tests since, but they haven't been able to replicate it.
I missed the majority of what you said. You're saying they haven't been able to replicate what? An infinity?
Well, just said that this team's claimed superconductivity before at room temperature, and they've had to redact that before. And now there's already been like 2 experiments since which can't replicate the superconductivity at room temperature.
Hey, just to clarify, do you think it's physically impossible?
No, God, I hope not as well.
Okay.
It's kind of just this team is a bit sus.
What if they had a thing where they had 5 sigma certainty? How would you feel about that?
I mean, if they had a 5 sigma certainty, I mean, that's basically a given.
It's basically a given, right? What would you say if there is a scientist right now named Krupa that says that cold, dark matter has been disproven by a factor of 5 sigma? What would you say to that?
I would say he's the scientist that's like actively working against dark matter. He's the Moad guy. So I don't know. Maybe.
Like
Wait. Did you say
a
All
nail
dark
that's
matter.
sticking out type deal?
Wait.
A nail that's sticking out? That like that?
Did you say cold dark matter? By the way.
Yes.
Oh well, then yeah, that's kind of a, or at least how we understood it. That's kind of a theory of the past.
What theory of the past? So you agree that cold, dark matter does not exist?
In the way that we used to think about it, no.
So how do you think about it now?
No, sorry. I'm not saying that there is a way or there isn't a way now. I'm just saying the way this thing, the way we thought about it, what we defined it as like a couple of years ago is definitely wrong. That has been very much thrown out.
Wow, okay, you're the first one that said this. Okay, so do you understand the implications then? If cold dark matter is not a thing, do you understand the implications of your cosmology?
Well, it might not be that cold dark matter isn't a thing. It's just the way we defined it and the way we thought about it before is not correct.
So something
But
would have to replace it then that has the exact same attributes or non-attributes, to be more exact here. Would you agree?
something would, at least the theories we're going by now for cosmology, we do need something to replace this cold dark matter.
Yeah, that's 30% of the universe. That's not just a little thing. So
You guys aren't using the. Hold on, Essie. You guys aren't using the lambda CDM model anymore. Then that's that model's done.
Sorry, explain that, Jeremy.
The lambda CDM model. You guys, that model's not get used. Doesn't get used anymore because we know cold dark matter is not a thing. Or what are you saying?
Well, I mean, like I said, cold dark matter might still be a thing. It's just the way we defined it and used to think of it was definitely wrong.
so what are the implications of that then?
No, so you're saying it's still a thing. No, hold on. So you're saying it is still a thing, and this guy's wrong on his recent findings.
He's saying it's another thing.
Yeah, I'm saying it needs to be something different to what we used to think about it, if it is a thing.
But it has to be a thing for your model to work, bro. This is the paradoxical nature of this.
How do we? Well, let's get into that. What defines a thing to be a thing?
Well, in this case, they need a thing to explain the movement of their galaxies that were wrong with the previous estimations of gravity. So this thing has to be there, or else gravity is gone in the way they understand it.
Does the thing have to be materially existent? Who are we talking to? Pick a username.
What does that mean, Dicelo?
Meaning, in order for a thing to be a thing, it has to be quantifiable in the sense that there's something tangibly existent in order to quantify it.
Yeah, for a thing to be physics rather than metaphysics, it must interact with something in the universe.
And when you say interact, what are we saying?
Literally anything. It could be shooting a beam of light. It could be forces. It could be fucking anything. As long as it has some form of interaction with literally anything else in the universe, it is physical
Right.
rather than metaphysical.
Right. A physical thing interacting in the sense of materially existent.
Yeah, it's just the difference between physics and metaphysics.
No, I understand that part. Now I'm trying to hash out the difference between perceivability and tangibility in the sense of material existence, i.e., a thing.
I'm not understanding you then.
So when you say dark matter, are you implying that it's material?
Yeah, it interacts with other stuff in the universe, yeah.
And what's the composition of the material?
Well, that's kind of the point. We don't know right now. That's why it's called dark matter.
Well, that's kind of the problem, though. Is it's seemingly unextractable, meaning that it's not actually a material thing, although we see its perceivable interaction. But this is the problem: is you're perceiving reality through the lenses of a materialist, i.e., an atomist, versus somebody who understands field dynamics. And this is where you guys have fallen off the wagon, in the sense that you've never defined the intrinsic property which unifies all things in phenomenal reality, being magnetism. That's the problem. So when we understand what magnetism is, and you understand that it's comprised of the loss of the dielectric field, then you'll quickly see that we've got these two fields interacting, which are actually but one field, and that the loss of that primary field, being the dielectric field, is what breeds mass magnitude, i.e., magnetism. And this is how we get space. This is how we get material existence. And this is how we get light and matter. All explainable, very simplistically.
You're not using dielectric correctly. What do you mean by dielectric?
Dielectric being the primary half of the ether field.
Oh, yeah.
It's so you got these two conjugate geometries, which are the antithesis of one another, yet simultaneously synonymous with one another, being the hyperboloid, which is the geometry of this dielectric field, and then you've got the toroid, which is the geometry of the magnetic field. And they're the negative images of each other. They're superimposed of each other, meaning that they're inseparable. So when you understand that, quickly see that we only have one field where light, electricity, and magnetism exist within, only ideated as being different due to their manifestations.
Man, that's a big one from Ken. Jesus Christ. How
Well,
does
this
he
explains
come
dark
up with this
matter.
stuff?
This explains dark matter. This makes nature very simple in understanding, not overcomplicated like quantum's done, bastardizing everything into,
You say that it's simple and not complicated, but I asked you to define like dielectric, and you go on this like 2-minute session of fucking toroidal fields and superimposing, and it's like what does that mean? What does any of
that
this
means
mean?
that means that when you look at that magnetic field under a ferrocell or supercell, and you look at those magnetic flux lines, they're interlaced with this other field. It seems like you've got these black lines, which is the dielectric, and you've got this black portal in the center of that visible magnetic field, where everything seems to be emitting from, coming from, and back to. So
How could I detect a dielectric field?
So you, like I just said, if you look at, if you have a ferrocell or a supercell where you visibly see the magnetic field, you're going to see the dielectric field synonymously intertwined within this magnetic field.
When I have
So
one of
it's-
those, I see a magnetic field. How do I detect a dielectric field?
it's visible. It's the opposite. It's wherever you see the light is the magnetic flux lines, and wherever you see the black is the dielectric. It's that simple. So it's just dielectric is just the capacitance potential of counter space essentially. So the loss of the dielectric is what we call magnetism. So when you have increasing potential terminating towards and into counter space, which is that black center nexus of that ferromagnetic field that's visible, you've got that's counter space. Counter space, the dielectric field are synonymous.